We are in outer space. Alrighty. So here we go. So the function I have here is one that we all know, and we already know the answer. And what we're doing is we're looking at increasing and decreasing functions in something called the first derivative test. And we're going to take a look at this particular function, which is f of x equals x squared. And right now, you need to understand this. What is the purpose of f? To find y. What is the purpose of finding the first derivative? Find slope. And so what we're going to do is find critical numbers. Critical numbers are those numbers in which make the derivative zero, either the numerator or the denominator. You have to look in both places. Why? Because those are potential spots for a term. Doesn't mean you're going to guarantee a term, but it's possible. So what I'm going to do here is I'm going to get 2x is equal to 0. And where did the 2x come from, Austin? It's the derivative of f. And when I solve for that, my critical number is 0. This is my critical number. I have one critical number. I have no others. And when you do this chart, the number of columns you're going to have here, you're going to create intervals. Since this is an open interval, it's going to go from negative infinity to my critical number. And from that critical number to infinity. Because something happens to the left of that critical number, either the function is increasing or decreasing, and something is happening to the right of that critical number. And so I'm going to put 0 here. Now, this is what I'm going to have called a test value. I can pick any number I want from negative infinity to 0. Any number you want. Yes, could I put a negative 10,000 into there? I could. I usually try to pick numbers that are easy. I could put a negative 3 in there. I'm going to choose a negative 1 and a positive 1. I choose easy numbers. And then I'm going to plug that in the derivative. So in this case, I'm going to plug it into the derivative and look at the sign. If I put a negative 1 into this derivative, is my derivative positive or negative? It's negative. What does that mean about f? F must be what? What did you say again? Decreasing. Now, this chart is for your organization. You cannot use the chart as a justification. You can use it as a way to gather your information. They're going to look at the chart, but they're not going to give you it as part of where it says justify your answer. Does that make sense? So when I put 1 into the derivative, it becomes what, Madeline? Positive. Okay? And so that means f has got to be doing what? Increasing. So I'm going to write the statements. If I look at the directions, it says determine the open intervals where f is increasing. Well, where is f increasing? What interval? Alex?
X is
Where's f increasing?
when x is greater than 0.
Okay, when x is greater than 0, right? And so I actually write the interval like this, and you can write it x is greater than 0. I'm going to say f is increasing from 0 to infinity, or where x is greater than 0, since f prime is positive in that interval. There's my justification. Yes?
How would that like justify it? Like, because you pick any number within. So let's say if you had it wrong and said like greater than 6, like you chose a number like 200. What if like the number 200 made it positive, but the number 175 made it negative?
Well, then there better have been a critical number between those two values.
So you would have had to screw up earlier.
Right. You would have had to come up with a different critical number. So in other words, since I only have one critical number, that critical number, if it has a turning point, has to be there. It's not going to be any other place. So what I do is I look to the left of it and I look to the right of it. There are some critical numbers, and hopefully I have time to get to it, that when you put a number to the left and put a number to the right, it stays positive. Well, then it's not a turning around point, is it? It's something else. Okay, and I'll get to that example. But because you only came up with one, you don't have to worry about any others. Does that make sense? Okay, good question. Okay, so then I'm going to say f is decreasing on what interval, Savannah?
Oh, negative infinity
To 0, since f prime is less than 0 on that interval. This is okay. This is okay. You have to use the word increasing. This is Kruger's symbolism. They want you to write the word out. Okay? They're not going to know what that means. Why does this group of kids use the down arrow? And they're all from Sauk Rapids.
Can we write like the down arrow like on our homework?
Yeah, for sure. Okay?
Just like on-
Because that homework is yours, and they'll understand what it means, but when you write your justification out, they're wanting sentences with words. Okay? You're okay doing this. They're fine with that, because that's a universal symbol that shows positivity. Okay? All right, now, the thing that it's asking is, what kind of point is that?